Hello, greetings. My name is Kishontan Krishnan. My matrix number B0818103115. Okay, today I would like to present our electronic system assignment. To begin with my presentation, I would like to introduce my team members. First, I would start with me, myself, Kishontan Krishnan, Mohammad Shauki bin Mohammad Akmal, Anas Faruqi bin Azhar, Azizul Akimi bin Ibrahim, and Mohammad Yusuf Ishraf, Mohammad Aziz, and then lastly Gayatri Saravanan. Okay, firstly, for my part, I have done oscillator 1 circuit. The given requirement was Wayne bridge oscillator, and the resonant frequency is 1 kilohertz, and the supply was 15 volts. Okay, first, for the designing purpose, I have to do some calculation to get the components value. For that, first I need to find the resistance value. For this, I assume the capacitor value as 1 nanofarad. By using this formula, I've computed and obtained the resistance value as 158 kilohertz. Sorry, 158 kilo ohms. Next, I need to find the variable resistance value. For that, based on this formula, I assume the gain as 3 and the R1 as 10 kilohertz. So by computing this formula, obtain the variable resistance value as somewhat between 20 kilo ohms to 22 kilo ohms. I chose 22 kilo ohms. By using that calculated components value, I've constructed the oscillator circuit in the multisim, which is over here, and this was the output I obtained from the circuit. Okay, now I've attached this circuit and the output in my report. Okay, just to let Sir know, what you have done here is we have separately included the discussion topic at each of our circuit explanation separately, but for the final report, we have combined all it together at the end. Okay, what I can conclude and discuss for this oscillator circuit is um, a Wayne bridge oscillator circuit is it's a type of electronic oscillator that generates sine wave. It can generate a large range of frequencies. Okay, for my circuit designing and construction, I have included 4 resistors and 2 capacitors. The oscillator can also be viewed as a positive gain amplifier combined with a band pass filter. It can also provide a positive feedback. Then overall, this construction of this oscillator that has been attached above in my report is based on the requirements given, which are resonant frequency 1 kilohertz and the DC supply 15 volts. That's all from me for oscillator circuit 1. Then I'll pass it to my friend for the next circuit. Thank you so much.
Hi and Assalamualaikum. My name is Anas Fauki. I will show you the report for the oscillator 2. So the type of circuit we use is on which oscillator. The frequency given is 20 kilohertz. This is supply is 15 volt. So from the frequency given 20 kilohertz, we use this formula to get the value of resistor. We assume the capacitor is 3 nanofarad. Okay, this to find the value of R1 and RF by using the voltage gain formula. So this is the circuit that I do. Okay, same goes to here, the same result. Okay, for this discussion, from the question, we need to design a Wayne bridge oscillator circuit. Is required to generate a resonant frequency of 20 kHz. We need to calculate the value of frequency determining resistor R1, R2 and the capacitor C1, C2 to produce the required frequency. From the result, we conclude that the value of output frequency is not the same with the frequency given. This is because the round-off value of the resistor, which is here. That's all for me. Thank you.
Hi, my name is Gayatri Saranan, metric number B0818101993. I'm going to explain about voltage summing and active low pass filter. First of all, what is voltage summing? Voltage summing is an op-amp circuit which is used to combine the voltage present on two or more input in a single output voltage. In this case, we use voltage summing to combine the output voltage of oscillator 1 and oscillator 2. Here is the circuit, and we have calculated the output voltage. This is the calculation, and this is the output we found from the simulation in multisim. This is the output. That's all. Given is active low pass filter, second order Butterworth response. The given cutoff frequency is 8 kHz. From the Butterworth response, we can know that the second order is R3 over R4 equals to 0.586. Okay, from the Butterworth response, we need to identify the value of R4. So, from the Butterworth response, we assume the value of R3 as 586 ohm. Using the value of 586 ohm, we need to identify the value of R4. Thus, the value of R4 is 1 kilohertz. In this circuit, they have not given the value of capacitor. Thus, we have to find the value of capacitor. Using the formula Fc 1 over 2 pi Rc, let R equals to 1 kilohertz. Then we have to solve the equation. We find out that capacitor is 20 nanofarad. This is the circuit design, and I have drawn the circuit design into the multisim. This is the simulation of the multisim. From the simulation of multisim, I have found out AV. AV equals to 4.03 dB. And this is the output using 4 channel oscilloscope, and the V out is 14.106 voltage, and this is the board plot. From the board plot, we have find out the FC. The FC is 8.121 kilohertz. From the board plot, we can identify that the frequency response curve drops at cutoff frequency. The cutoff frequency where the response drop at, this is the negative 3 dB from band pass. This is the band pass. In high voltage gain, when the input signal at low frequency, the signal will pass through the amplifying circuit directly. But if input frequency is high, the signal will pass through the capacitor. Thus, output signal amplitude is increased by band pass gain. Okay, we can know that for non-inverting amplifier, the magnitude of voltage gain is obtained by its feedback resistor corresponding to input resistor. We can find out the voltage gain here, and this is the voltage gain just now I mentioned. That's all. Thank you.
Hello and Assalamualaikum. My name is Azwar Hakimi, and today I'm going to explain about full-bridge rectifier. So this is the full-bridge rectifier circuit. It produces an output or current which is purely DC. So from AC to DC. So the full-bridge rectifier circuit, the average DC output is higher than half wave rectifier. It also has much less ripple and produce a smoother output waveform. So I'm going to explain to you the positive half cycle. So the diode 1 and diode 2 is in series, while the diode 3 and 4 are reverse bias. So what happens is when the current transfer through this diode, and these two diodes will allow the current, and these two are reverse bias. So it will transfer and goes to the load, which is R1 and capacitor 1, and will transfer back to the diode lah. And when the negative side, I mean the negative phase of AC current, so the negative part will goes to the D3 and D4. So D3 and D4 is in series, and D1 and D2 is in reverse bias. So that's how we produce the DC board lah. So we using capacitor 220 microfarad as a, what do we call it, as a filter of this circuit, as a filter. So basically I'm using, by the way, I'm using 20 volt peak as the input, and what will happen is this waveform. So this is the this is the the input the input signal, and this is the output signal. Uh, so the input signal is alternating current, and the output signal is direct current. So by the way, we're using capacitor to filter and making the signal more smooth lah, more smooth. So this is the calculation. So from the output, from the circuit, we can calculate the BRMS and BDC. So BDC is 12.73, and the Vout is 20 minus 1.4 volt. Why 1.4 volt? Because each time the D1 and D2, I'm sorry, the D1 and D2 goes through this, it will there's a 0.7 loss here. The same goes with D4 and D3. Yeah, there's a 0.7 volt loss here. So that's why we take the BP in, and we minus with 1.4. So and then this is the how we calculate the V ripple with current over frequency times with capacitance, and we got 2.838. So the circuit, this is the circuit design. Okay, so the input voltage is 20 volt peak, and the output voltage is 19.3 volt peak. Okay, so that's all. Thanks.
Assalamualaikum and hello. My name is Muhammad Syakir Muhammad Kamal. Today I would like to present about the assignment. My part is voltage regulator. First, I will show the calculation for the circuit. The VO and the IS are provided by the equation, which is 5 volt and 0.8 ampere. The first step is we must find the VZ. The general formula is VL equal VZ plus VBE. So VZ will be 4.3 volt. Next, we must find the IL. We are assuming RL is 100 ohm. So IL will be 0.05 ampere. Next, we must find the RS. We are assuming Vin is 10 volt. So the formula for IS equal Vin minus Vz over RS. So RS will be 4.63. The last step is we must find the IC. IC equal IS minus IL. So the value will be 0.75 ampere. So next I will show the simulation of circuit. So this is the basic shunt voltage regulator circuit. I'm using 10 volt for the source. This is RS, this is Zener diode, this is transistor, this is RL. So the first multimeter is show for VL. The value that I get is 5.691 volt. The second multimeter is for IL. So the value that I get 56.914 milliampere. The third multimeter is for IS. So I get 857.458 milliampere. And the last multimeter is for IZ. I got 930 and 58 milliampere. So basically the result from the simulation that I got is almost same from the calculation. So that's all. Thank you and bye bye.
My name is Muhammad Yusuf. Today I will present about assignment electronic system. For my part is load. So given the load rated power V0 is equal to 1 watt. So this is the result for the load circulation. This is the circuit and the output for voltage is 5.237 and the 09.48. So from the voltage rectifier circuit, you can get the load circuit by converting the alternating current to direct current. So shown in the figure. I think that's all. Thank you.
Back. Now we'll talk about our final completed circuit. Okay, as you can see here, it's starting off with two oscillator circuit, and the output from it enters the voltage sum circuit, and through that it enters low pass filter, and output from the low pass filter enters the full bridge rectifier circuit, and finally it enters the voltage regulator load circuit. Okay. These are the output for the each circuits. As you can see here, channel 1 indicates the output for voltage summing, which is the combination of oscillator 1 and oscillator 2. Channel 2 indicates the output for active low pass filter, and channel 3 indicates full output of full bridge rectifier, and finally channel 4 indicates the output for voltage regulator. And yeah, that's it from our group for this electronic system assignment. Thank you for listening. See ya.